Dividing polynomials. Our objective is to divide a polynomial by a monomial or binomial. Why learn this? Division of polynomials can be used to compare the energy produced by solar panels. So let's start with dividing a polynomial by a monomial. So if it helps, you can rewrite it so it says 6x to the third plus 8x squared minus 4x, and that can go over 2x. Now, notice how this is a trinomial. That means when you go to divide, you don't just divide the 6x to the third by 2x. You divide all three terms by 2x. So, if we were to divide the 6x to the third by 2x, we would end up with 3x squared. And now we do the next term. 8x squared divided by 2x is going to be a positive 4x. And then negative 4x divided by 2x is going to give us negative 2. And that's that. Take a moment, pause the video, and try these next two on your own. When you return to the video, the answer for both will be revealed. So similar to the way we did the last problem, we have our 8p to the third divided by negative 4p squared. That gave us negative 2p. Negative 4p squared divided by negative 4p squared, well, that's just positive 1. Negative divided by negative is a positive. And then we get a little bit more challenging. We have 12p divided by negative 4p squared. In this case, there's going to be stuff left in the denominator. That's okay. Just leave it there. So, in this case, we reduce, and we have a 3 left on the top, or in our numerator, and then a p in our denominator. So our end result reads negative 2p plus 1 minus 3 over p. The same thing happened in problem C. When you divide each piece, you end up with x squared plus a third minus 5 over 2x. So if you need to, you can write out this middle step here and make sure that you accurately divide each piece. So when dividing polynomials, step 1, factor the numerator and or denominator if possible. So if we can factor the numerator or denominator, please do so. Step 2, divide out any common factors. So we don't need r plus 2 and r plus 2 in this case, so we're left with r plus 1, and that's all we've got left. So let's try a few examples. So we have c squared plus 4c minus 5. So we want to factor our numerator and denominator if possible. So our numerator, we're going to be left with c. We want two numbers that multiply to give us negative 5, but when we add them, give us 4. So we want positive 5 and negative 1. And that's going to be over c minus 1. So there's a common one in place, so we cross those off, and we're left with c plus 5. Keep in mind, when you cross things off, it doesn't equal 0, it equals 1. Because c minus 1 divided by c minus 1 is equivalent to 1, not 0. So it is c plus 5. Take a moment, pause the video, and try this next one on your own. When you return to the video, the answer will be revealed. And there you have it. Let's try another one. Take a moment, pause the video, and try this one on your own. When you return to the video, the answer will be revealed. And there you have it. So recall how you use long division to divide whole numbers. You can also use long division to divide polynomials. An example is shown below. So if we have 23, how many times does 23 go into 34? Once. So we put a 23 down the bottom, we subtract, we end up with 11. We bring down the next number. So how many times does 23 go into 115? 5. 23 times 5 is 115, which leaves us with a remainder of 0. You can follow a similar pattern when dealing with polynomials. This is an excellent way to divide when your trinomial is not easily factorable. In this case, you could have easily factored x squared plus 3x plus 2. However, for the purpose of learning, we're going to use this to learn how to use long division with polynomials, because sometimes that is not always possible. So we ask ourselves, what times x is going to give us x squared? Well, in that case, x. So x times x is x squared, and x times 2 is 2x. And we still subtract. So x squared minus x squared is 0, and we have 3x minus 2x, which is x. So then we ask, x times what gives us x? 1. 1 times x gives us x, so 1 times 2 is 2. And then we subtract. And we're left with nothing, so no remainder. And when you were to divide x squared plus 3x plus 2, if you were to have factored, you'd have an x plus 2, x plus 1, which then translates to the fact that if you divide by x plus 2, you're only going to be left with an x plus 1. So let's look at a few steps first. So, step 1, write the binomial and polynomial in long division form. Step 2, divide the first term of the dividend by the first term of the divisor. This is the first term of the quotient. Step 3, multiply this first term by the quotient of the binomial divisor and place the product under the dividend, aligning like terms. Step 4, subtract the product from the dividend. Step 5, bring down that next term. And step 6, keep repeating these steps until you get 0 or until the degree of the remainder is less than the degree of the binomial. So let's try. So let's set it up so we can do some long division. So we have x plus 2, and then we have x squared plus 3x plus 2. Keep in mind, we want to make sure we set things up in order. X squared, then 3x, then 2. So if we had a fourth term in here, you would go x to the third, x squared, x, and then your constant. It has to be in order, and if there's nothing there, you need to put a 0 in as a placeholder. Otherwise, this whole process is not going to work out. So what times x is going to give us x squared? Well, in this case, x. So x times x is x squared, and x times 2 is 2x. And then we subtract. So we're left with 1x. Bring down our next term, so plus 2. So what times x gives us x? Plus 1. So we end up with 1x plus 2. When we subtract, we end up with 0. So we are done. Our end result is x plus 1. Let's try another one. So we have x plus 1 outside, and on the inside we have x squared plus 4x plus 3. So we ask ourselves the question, what times x is going to give us x squared? X. So now we're left with x squared plus 1x. We're going to subtract, so we're left with 3x, and we bring down the next term, so plus 3. So what times x is going to give us 3x? 3. So then we end up with 3x plus 3, and when we subtract, no remainder to worry about, so we're just left with an x plus 3. Take a moment, pause the video, and try this next one on your own. When you return to the video, the answer will be revealed. And there you have it. The process is still the same. Please be careful. When you're subtracting, if it's minus a negative, it's like adding the opposite, so adding a positive. So if you have negative 5y minus negative 6y, you're going to end up with 1y. Take a moment, pause the video, and try this next one on your own. When you return to the video, the answer will be revealed. And there you have it. So, now let's try long division with a remainder. Everything gets set up the same. Keeping everything in order, we don't have to worry about putting a 0 value in for anything. So, we go back to our original. What times x gives us 2x squared? 2x. So 2x times x is 2x squared. 2x times negative 2 is negative 4x. And we're subtracting. So 3 minus negative 4 is 7x, and then we bring down our next term. So x times what is 7x? 7. So we have 7x minus 14, and then we subtract. So 7x minus 6 minus 7x minus 14 is going to leave us with 8. That's our remainder. So how to write our remainder is if it's positive, it would be a plus. If it was negative, it would be a minus. So our remainder would end up coming out, so we have 8 over x minus 2, and it's positive. We're basically going to take this value and we're just going to add it to the back side here. So we're going to have 2x plus 7 plus 8 over x minus 2. Take a moment and try this next one on your own. When you return to the video, the answer will be revealed. So all of our steps are the same. I just want to re-go over this last piece with the remainder. So when you were all said and done, you ended up with a remainder of 13. This 13 goes over what you were dividing by. So just like when you were doing remainders back in elementary school. Your 13 goes over what you started with here, or what you were dividing by. So it's a positive, so plus 13 over m plus 3, and you just tack it on to our 3m minus 5. So we end with that. So now let's look at dividing polynomials that have a zero coefficient. What I mean by that is notice how when we're dealing with this, we have x to the third and then we jump to an x. You need to have a place value for that x squared. Well, since it doesn't exist, you're going to have a zero coefficient. So let's write this out. So we've got 2x plus 3, and that's going into negative 4x to the third plus 0x squared plus 3x minus 15. So since there was no x squared, we needed a placeholder. Otherwise, everything is going to be shifted, and when you subtract, things aren't going to line up. Because remember, you want like terms when you're lining things up. And whatever sign was in front of the coefficient, you keep it. So if it was a minus 4x to the third, it's a minus 4x to the third. That doesn't change. So then we go back to our old school questions. What times 2x is going to give us negative 4x to the third? Well, in this case, negative 2x squared. So we had negative 4x to the third minus 6x squared. And then we subtract. So minus a negative, so we're going to be left with 6x squared, and then we bring down our next term, so plus 3x. And we ask ourselves our old question here, what times 2x is going to give us 6x squared? Well, in this case, a good old 3x. So 3x times 2x is going to be 6x squared, and then 3x times 3 is 9x. And then we subtract. This leaves us with negative 6x, and we bring down this minus 15. And then we ask ourselves the question, what times 2x is going to give us negative 6x? In this case, negative 3. So we have negative 6x, and then negative 3 times 3 is a minus 9. And then we're subtracting. So negative 15 minus negative 9 is like saying negative 15 plus 9. So we get negative 6. Our remainder has a minus, so when we finish writing it, it's going to have a minus. So we have negative 2x squared plus 3x minus 3, and then minus 6 over 2x plus 3. Remember, our remainder goes over what we were trying to divide by. And this ends our video lesson on dividing polynomials.